Hello and welcome to my next episode of a tutorial series on FM sound design using the Sonicware Liven XFM. So far we've covered some of the basic panel features of the Liven XFM. We introduced the morphing capabilities to make sounds without real understanding of FM synthesis. Then we dived into the FM panel mode. One operator FM was done last episode. Today we're going to cover two operator FM. In a sense, you could consider this the most basic synthesis form that would be traditionally considered FM. So I've turned the device on, and as we've done previously, I'm going to go into edit mode. I'm going to load any patch, then I'm going to convert it to an init patch. So here we have a sine wave. I'm going to take this opportunity to step back a little bit and discuss exactly what FM synthesis is and what makes it different to subtractive synthesis, which is what people tend to be most familiar with. In FM synthesis, rather than having a single or a couple of complex oscillators which get summed together, by complex I mean containing a harmonically rich sound, we have a series of operators which generate sine waves. A sine wave is considered to be a pure waveform and contains only one harmonic, which is the fundamental pitch, or another pitch if you choose it to be. In FM synthesis, we use a set of sine wave oscillators, known as operators in FM language, to modulate the pitch of one another. Why might you modulate the pitch of one operator with another? Well, that's because as you modulate one sine wave with another, that's to say the waveform of one sine wave is adjusting the pitch of another oscillator, you introduce new harmonics. Specifically, if the modulating wave is an integer multiple of the frequency of the original wave, and we are doing linear FM, which is what's happening here, you will introduce harmonics. If the second oscillator, the modulating oscillator, is not tuned to a harmonic of the sounding oscillator, which we might call a carrier here, then the output will contain inharmonics. So FM synthesis is known for its capacity to make inharmonic sounds, such as bell tones, and to make harmonic sounds. So the way that the operators are connected in traditional FM synths is referred to as an algorithm. An algorithm means that the following oscillators or operators are known as carriers, which means they feed the mixer. The following other operators are known as modulators. They do not go to the mixer, but they do get used to modulate other operators. As I mentioned previously, on the Liven XFM, the concept of algorithms doesn't exist in the traditional sense because every operator is connected to and can modulate every other operator, and all of the operators can output to the mixer. So you can think of it as having a single algorithm, which is a fully connected graph of operators. So I'm going to jump in and illustrate how this works, first by looking at one oscillator like we did last time, so you can hear what it means to modulate. So, sine wave. Let's look at the mixer. Operator 1 is turned up, all the other operators are turned down. Now I'm going to introduce some feedback on operator 1. So I'm going to set it to 0. Positive feedback. This is the operator modulating itself. We get a sound that's reminiscent of a saw wave. With negative modulation, this means the sound is modulating itself with an inverse of its waveform. We get more of a square waveform. So you can hear we have the two waves that you would typically expect to hear on a subtractive synth available to us. So let's talk about introducing a second operator, and let's listen to what that sounds like. So what I'm going to do is think about the number of ways we could use two operators in a synth like this. Well, firstly, in the simplest sense, both operators could be sent to the mixer directly. So let's do that. Page 1, turn up operator 2. Doesn't sound very interesting. Why? Because both operators are outputting the same pitch. So let's look at the frequency ratio dial. So the dial, notice it goes in integers, and in fact it goes down to 0.5. What does this mean? Well, this is the ratio of the fundamental pitch of a given note I am playing and the note which will sound. So let me turn down operator 1 and let's just listen to operator 2. So currently the ratio is, let me do this. Currently the ratio is set to 1, meaning that we are hearing the fundamental of the note. If I adjust the tuning away from 1, 0.5, half the frequency is 1 octave below. Double the frequency, 1 octave above. This is 3 times the frequency, so this is a fifth in the octave above. 2 octaves above. So you can hear what we have here is a harmonic series going on. In addition to staying on pitch, we have the capacity to what they call fine tune. So I'm not limited to the harmonics, these integer multiples. We can access these non-integer multiples too. So that's listening to operator 2 on its own. Let's bring operator 1 back in. And let's adjust the frequency. So now you can hear operator 2 is sounding an octave below. So even in this case, we've added some timbral interest. They're both at 1, we're at unison. Now we can hear operator 2 is above. Let's try adjusting the volume of operator 2. So even in this basic mode where there's actually no FM synthesis across the operators occurring, we can still generate some sounds which have more interest than just a pure sine wave. So let's take this a little further and let's add some feedback to these operators and see if we can generate a more interesting timbre. And then we'll move into having them modulate each other, which is really what we're looking to do here. So page 2, I'm going to set the knobs to 0. So this is my pair of sine waves. One of them is on pitch, operator 1. Operator 2 is at 2 times pitch, 1 octave above. So now let's try and introduce some feedback. Let's introduce feedback to operator 1 first. So you hear that more hollow square wave sound. Let's try and turn operator 2 into something more like a saw wave. Okay, so again, you can hear a timbral change. It may be interesting to use operator 2 as a sub-oscillator. Oops, I did not mean to do that. I just adjusted the level. I'm going to bring it back to the default level. And then I'm going to turn the ratio down. Now I'm going to try and turn up feedback on the second oscillator. So you hear that saw wave buzz there. So already we have something which sounds quite different, and we're not really cross-modulating. So what we're doing here is actually quite a lot like the oscillator section on a standard subtractive synthesizer. We're summing a square wave with a saw wave, and the result is something with more timbral complexity. Given that this synthesizer has a filter that you can use when you're sequencing, not in FM edit mode, we could simply use this as is, as a subtractive virtual analog type of synthesizer. But what we're really interested in today is how do we use one operator to modulate another to interesting effect. So let's jump straight into that. I'm going to demonstrate what it sounds like, and then we're going to design a sound using this, having gone back to the init patch. So operator 1, these are the mixer receive levels. So you can see the mixer receive level for itself is -13. That's a negative feedback amount. Operator 2, 3, and 4 there is no receive level. In other words, operator 1 is not being modulated by any of the other operators. So let's play. And now what I'll do is I'll turn the feedback amount up. This is the amount of modulation from oscillator 2 that operator 1 is receiving. So interestingly, as that amount goes up, it sounds very much like a filter opening and closing, a sort of formant-like sound. And that is one of the best ways I've found to think about FM synthesis. Normally with subtractive synthesis, you're using a filter to remove harmonics. With FM synthesis, you're using modulation to introduce or add harmonics. So you can think of the operation of modulation as being the inverse of the operation of a filter. So let's just pick something that we like the sound of. Something a little bit buzzy. I think that's quite interesting. Let's jump over to operator 2. This is the operator 2's receive level from operator 2, in other words, feedback. Let's look at the modulation level of operator 1 going to operator 2. Okay, so I think we have something here that's kind of buzzy, it's quite interesting. I think there's a lot more timbre here. One of the things we could jump straight into, which I guess I'll do very quickly, is we could simply add some envelopes here. So what I'll do is I'll have operator 1 function like a sort of plucky sound. I did this in the last episode, so I'm not going to go into too much detail about how this is done. We have the ability on this synthesizer to mute operators by pressing the button a second time. So I'll mute operator 1, unmute. So this is operator 2. So you can hear I've made a little plucky sort of envelope there. I'm going to jump over to operator 1. And I'm going to make a more sustained sound for this. So let's say this goes down a bit. This goes down a bit more. This goes to 0. I'll talk about this in a little more detail when we're actually designing a sound. For now, I'm just trying to dial something in pretty quick. So notice when I mute operator 2, it's not only muting its path to the mixer, but it's also muting its modulation effect. So listen what happens when I bring operator 2 back in. So you hear that we're no longer just hearing a volume change. We're actually hearing a change in timbre as the sound evolves. Very much like if we had a filter that we were closing. So in fact, let me mute operator 2 and just let you listen to operator 1 alone. So you hear it has a sort of buzz which fades out into something like a sine wave. And in fact, we can listen to operator 2 if we wish. Okay, so I think this gives a little flavor of how this works. You may have seen some subtractive synths provide a sort of FM algorithm. What really differentiates a true FM synth from one of those FM algorithms that's provided is that in a true FM synth, typically you have an envelope available to adjust the volume of each of the operators. The volume adjustment on the operators allows us to adjust the timbre of the other operators that they are modulating. So this is quite effective. I'm going to jump back to an init patch and we're going to design ourselves something of a lead sound. So when I'm thinking of a lead, a 2-operator lead, I'm thinking I'm going to use operator 1 to be the main shape of the sound, that classic ADSR lead type of sound. And operator 2, I'm going to shape into something like a pluck. And the pluck is going to give us a sort of buzzy transient at the beginning, which is going to fade out as the sound proceeds. So let's start by shaping the first sound and shaping the second sound, leaving them as sine waves, and then thinking about exactly how they're going to interact with each other afterwards. So operator 1 is up, operator 2 is down. We can see them on the mixer panel. So just the sine wave. So when I'm thinking of a classic ADSR envelope, I'm thinking that the sound will go I'm thinking that the sound will go up to full level, it will drop to some sort of decay level. In this case, we can have it drop further during the sustain. So I'm going to pick another level in the sustain, let's say 60, and then it'll drop down to 0. At the moment, the times are very short. So what you can hear is the sustain level. So if I want, I can turn the sustain level up a bit. Say 70 makes more sense. Okay. This can go a little higher. Say 95. Okay. So now what I'm going to do is adjust the time for each of these. So what I'll do initially is I'll just set them all to something so we can hear. So we can hear swell, drip, down, and then it fades away. Okay, so let's think about the attack portion of that sound. I think that's too soft for now. Okay, so that's a bit more of a punchy attack. You hear the decay is quite fast, so let's make it a little longer. Okay, and the sustain. This is not usually available as a time on other synthesizers, but probably I want it to be quite long. So what we have here is a rise, a drop, and then another drop, and then finally the release. So let's listen to the release. A bit too quick, I think. So the voice mode I had was polyphonic. In this case, I'd probably play legato. Okay, so legato is mono legato mode. Now we have that sound. Now what we're going to do is, in the same way as on a subtractive synth, we would shape the filter envelope, I'm going to shape the movement of another operator. And if we imagine what would be happening with the filter envelope, we would be opening the filter and then closing the filter with time. That would be giving us a transient at the beginning. So the way we're going to simulate that transient is by making pretty much exactly the same shape, a rising and then gradually falling sound on the second operator. And we're going to use that second operator to modulate the first operator to give us this attack sound. So what I'm going to do is only listen to the second operator so we can try and set the shape of the envelope the way that we want it. Yeah, I think that makes sense. So what I'm actually going to do, I just thought, is maybe rather than only listen to the second operator, oops, I didn't mean to adjust that. Rather than only listening to the second operator, I'm going to leave the first operator in, and I'm going to set the first operator to a lower pitch. So that continuous tone on the top is operator 2. And below there is operator 1. I'm only putting these side by side just to help myself hear them. So operator 2, I'm going to now go through and edit the levels. Maybe to make it a little easier to hear, I'm going to immediately set some times. So okay. So now we're going to set the levels. So I think just like before, we want the attack to go full. The decay, we want it to decay down to 0 because we want this to be a plucky sound. So we'll want the sustain to 0 and we'll want the release to 0. Possibly, maybe we want a little bit. We can go back and tweak this afterwards if we decide we want a little bit more of the modulation sound in. we'll be able to increase these levels. But more importantly, let's look at the times. I think I like that little opening sound, sort of maybe like a brassy sound. Okay, and let's set some release. Okay, so now we have our two operators in place. I'll play them soloed so you can hear how they sound. Operator 1, operator 2. So now we're getting to the point of modulating these things. So what I'm going to do is I'm going to listen only to operator 1, and I'm going to modulate operator 1 with operator 2. Let's step back and think about how this should sound. What should happen is, as operator 2 fades in, the timbral complexity of operator 1 should increase. It should become more buzzy, more harmonically rich, and then those harmonics should fade out as operator 2 decays. So let's just try it. This is what we have. Let's add a lot of feedback. Okay, so maybe that's a bit too much feedback. Too much modulation. Okay, I think that's getting to the shape that I want, but I find that once it fades out to that sine wave, it's a little bit too plain. It doesn't really have enough character. So there are two things we can do about that. The first thing we can do is we can increase the sustain level on operator 2. So I'm going to jump over to operator 2, look at the levels. So what I'm going to do is bring the level of the decay and the sustain up. If I left the decay at 0 and I had the sustain up, what would happen is the envelope would close and then it would reopen. And I don't want it to close and reopen. So when the decay and the sustain are at the same level, it behaves more like you'd expect from an ADSR envelope. So let's listen. So it doesn't quite go all the way down to the sine wave. The other thing we can do, which I think is going to be more important here, is we can adjust the feedback amount on operator 1. This feedback amount is going to make, instead of it drop down to a sine wave, to some other timbre. So let's try. Okay, so this is more towards the saw wave side, and I'm going to turn it to the other side. So we have this parameter here, a secondary parameter of velocity, which is the portamento amount. So I feel like at the moment it probably becomes a little bit too quiet on the decay sustain portion. So let's look at the levels. I've got this at 95, so I'm going to bring this up to, let's say, 105. And this sustain is 71. I'm going to bring this to 95. So let's listen again. And I feel like I would like operator 2 to have more ongoing impact to keep that buzz going. So let's go to operator 2. Let's look at the levels, the decay and sustain levels. I'll bring it up to 45 and 45. Okay, I think this is getting to the type of sound that I'd like. Let me experiment by adjusting the attack time on operator 2 to hear how we can shape that transient. So page 2, operator 2. I feel like this might be interesting polyphonically. but my intent was a lead, so I'll go back to... So maybe this decay, the rate at which the timbre softens, I can make it last a little bit longer. Okay, so we can experiment now with the possibility of adjusting the feedback levels. Now we have something we're reasonably happy with. We can adjust the feedback levels, but also we can experiment adjusting the pitch. So let's see what happens if we adjust the frequency of operator 2. So you can hear when we set the frequency to 3, 3 is a fifth. So we get something that's a little bit more biting, a little bit more interesting. Let's look at the feedback amount. This is sounding pretty good to me. Notice that at the moment I only have operator 1 turned up. We can still listen to operator 2. And we can include that in the sound. So let's bring operator 1 in. So now we can hear we have our lead tone in the front, but we also have a second tone coming in the background. So let's try it in a different register. It's pretty interesting. There are some other things which we did last time, which was adjusting the gain at different registers. In this case, since the sound I'm going for is a lead sound, it's a synthesized sound rather than an acoustic sound. So in fact, the time scaling is much less relevant, and the gain scaling is much less relevant here. If we wanted, we could choose to have less gain in the second operator up in the high register. I'm going to set this to an extreme level. I'm going to set the low gain extremely high and the high gain extremely low, and you should hear. So in the low register, we have a lot of modulation. And in the high register, the second operator is modulating much less. Probably this is a bit too extreme. And let's jump down to the low register. Okay. The only thing we haven't set here is velocity sensitivity, and effectively now we can think of operator 1 as representing the body of the sound, and we can think of operator 2 as reflecting the timbral complexity or the filter movement. So we might say that we want operator 1 to be a little velocity sensitive and operator 2 to be a lot velocity sensitive. So let's listen as we adjust the velocity. Maybe that's a little bit extreme, so let's turn that down a little bit. So now we can hear that on a velocity sensitive keyboard, at high velocity we'd have this buzz. As the velocity goes down, we'd have a cleaner tone. So it is a lead. It is a lead sound. But it has a more interesting timbre and shape to it. So I think this video has gone a little bit longer than I had intended, but hopefully it describes in a little more detail how to think about FM sound design and how to design a sound that is usable from scratch. Note we went from the init patch. So once again, thanks for listening. Next episode, I'm going to try and introduce designing a sound using 3 operators, which hopefully I'll make a little bit more concise. But irrespective, I hope you enjoyed, and see you next time.